Hello, chemistry students. Today we are going to combine the three gas laws that you have already learned. So, in this video, you will learn how to connect the relationship between temperature, volume, and pressure. Before we talk about the combined gas law, we need to define standard temperature and pressure. You will see this phrase STP listed throughout the rest of this course. And if you see that, that means standard temperature and pressure. And that tells you that the temperature is 0 degrees Celsius or 273.15 Kelvin, and that the pressure is 101.3 kilopascals or 1 atmosphere. So in a story problem, it'll say a gas at STP. That should clue you in that the temperature is 0 and the pressure is 1 atm. Here is the formula for the combined gas law. So this is a combination of Boyle's, Charles, and Gay-Lussac's law, where P1 is the initial pressure, V1 is the initial volume, and T1 is the initial temperature. After the gas goes through a change, it will have a new pressure, new volume, and new temperature, which is what is represented by P2, V2, and T2. And remember that each of these temperatures needs to be measured using the Kelvin temperature scale. And the equation to convert between Celsius and Kelvin is this one. Okay, let's practice. At STP, a gas sample has a volume of 20.0 liters. What would the volume be at 75 Kelvin and 200 kilopascals? So we are going to use the combined gas law. Now, what are they asking us for? Right here, what would be the volume? So they are asking for V2. Now we just have to list out the things we know. Okay, so here's our unknown. Right here it says at STP. So that's standard temperature and pressure. So we know P1 and T1. And the unit that they use for P2 is kilopascals. So that's the pressure unit we're going to use here. Okay. The initial volume is 20.0 liters. P2 is 200.0 kilopascals. And the temperature changes also. So two things are changing here, which is why we need to use the combined gas law. So the temperature changes to be 75 Kelvin. Okay, so we had a temperature decrease and a pressure increase. What is that going to do to the volume? This is the part where we plug everything in and do the math. Okay, I'm going to scoot this math over because in order to get V2 by itself, we're going to have to multiply both sides by the reciprocal of this fraction. And this will cancel out everything except for the final volume on the right. And it will cancel out kilopascals, and Kelvin. So our final unit is going to be liters. Now at this point, I'm going to plug everything into my calculator and find out what's on the top and what's on the bottom. When I divide the top by the bottom, I get 2.7814 liters. Now let's check and see. I can use only 3 significant figures. 1, 2, 3, and then the 1 will not affect the 8. So our final answer is 2.78 liters. A gas at 155 kilopascals and 25 degrees Celsius has an initial volume of 1 liter. The pressure of the gas increases to 605 kilopascals as the temperature is raised to 125 degrees Celsius. What is the new volume? So we need to use the combined gas law because both pressure and temperature are being changed. What are they asking us to find? Again, it's going to be the final volume. They say, what is the new volume? So now let's list out the things we know. Okay, so all of the initials are listed in the first sentence. So it has 155 kilopascals, 25 degrees Celsius, and a volume of 1.00 liters. The final pressure is 605 kilopascals, so our pressure is increasing and our temperature is also increasing up to 125 degrees Celsius. All right, now let's plug everything in. Let's scoot this over again because to get this by itself, we need to multiply by the reciprocal of these two values. And this will cancel out everything except for the final volume on the right. And it will cancel out Kelvin units and kilopascals on the left, leaving us with the final unit of liters. When I plug all of this into my calculator, what I'm typing in is 398 times 155 times 1. And then I'm clearing my calculator and typing in 605 times 298. And those are the values that I'm going to put down here. So there's that top number. And that needs to be divided by this bottom value. Then I clear my calculator again and retype the blue number divided by that green number. So it's important when you're doing these problems that you're actually writing down these numbers because there's no way to just type this much math into your calculator, you're going to have to write down 61,713.25 and then go back and re-enter it in. So when you divide those two, I get 0.3421 liters. There are there's only two significant figures right here. So 1, 2, and that 2 does not affect the 4. So my final answer is 0.34 liters.